Yes, welcome everyone again to the Australian Virtual Astronaut Challenge. I am so very happy to have you here, and I hope that you're really been enjoying the weeks that we've been having so far. My name is Ben Newsome from Fizzics Education. Really glad to have you here, and this is the getting your ideas out of your head. That's really what this is actually about. And before we get this going, I really want to acknowledge for sure that I am meeting with you in Western Sydney and lands of the Darug people. And I want to acknowledge all the traditional custodians of the various lands from which you all come from. And trust me, we're not just in Australia, we are around the world as well. And I really want to pay respects to our elders past, present, and emerging, and extend that to everyone who's involved today, and especially Aboriginal people who may be joining us today. This is a packed session. We have a lot of people involved in this particular hour that we've got. So we really are going to be really getting going. So we might just briefly introduce some of the people involved in here. So Dr. Scott Sleap, would you like to introduce yourself, please, sir?
Yeah, hi everybody, it's Dr. Scott Sleap here, coming to you from New South Wales, Wanneroo land. Really looking forward to this today. It's we've got awesome presentations for you.
Thanks very much, Scott. And Glenn Lawrence, I know that Kylie Burr is off to side doing some bits, but Glenn, would you like to say hi, please? Or might be just caught up for a little bit. That's okay. I will go across the credit to Gillian Hewitt from Imaginaturalists. Gillian, would you like to say hello to everyone, please?
Hi, everybody. Really pleased to be here today.
No, I'm really stoked you can be here. Now I can see Glenn is available. Glenn, is it right if you can unmute your video as well and say good day to everyone?
Hi, good morning, everyone. Thanks for joining in. We've got some great activities planned for you today. I'll be joining you very soon. In the meantime, if you've got some blank paper, any old paper and a pen or pencil, grab those and I'll be with you soon. Thanks.
Thanks so much, Glenn. Really looking forward to what you got coming from, well, what you do at Design Nuts. You guys do an amazing job. Now, of course, we can't do this without Wendy Bode. Wendy, if you'd like to say hello, please.
Good morning, everyone. I'm just logging in with you from Townsville, North Queensland, Wulgarukaba and Bindal people, and I'm seriously looking forward to today's lesson around creativity.
Same here, I've got to say. And I know someone who loves creativity is Ian Preston. Ian, do you want to say hello, please?
Yeah, hi, Ben. Hi, everybody. I'm coming to you from Murrumbidgee Regional High School, the home of the New South Wales Virtual STEM Academy, and we're situated in Griffith, New South Wales, home of the Wiradjuri people. So looking forward to today's session, and we've got some great stuff coming forward. So good morning, everybody.
Look, much appreciated. Thanks so much, Anne. And Ted Tagami from Magnitude.io has been able to join us, and he's going to be popping up very, very soon too. But right now he's going to pop up and say good day.
I get my buttons to work. Good. Wait, hold on a second. There we go. Well, good morning to you all. It's afternoon here in lovely Berkeley, California. We've actually got much needed rain. We've suffered from a drought here in California, home of the Ohlone, Native Americans here. I'm really looking forward to this session, Ben, and everyone, what they have to share.
Thanks so much. And thanks again to Peter Dowler and Jackie Cow, who are helping from Fizzics Education push the buttons and make stuff happen. So what have we done so far? We're on week 3 of a design process. And in this case, on the very first week, we thought, righto, we need to form a team to make this happen. How to make plants grow in some way, shape or form on the International Space Station or on the moon. Then we looked at really how does the ideation process work in week 2? How do we get ideas out rapidly? And how do we start thinking about managing our projects? Now, this week is all about getting our ideas out of our head and onto paper in a very, well, clear way. And by the way, one thing I did throw out to you last week was training like an astronaut. I did talk about the heart and getting ourselves ready. I'm just curious, have you been doing some exercise? I have. I probably should be doing some more, trying to get our heart rates down and our fitness levels up. I thought though, seeing that we talked about the heart, why not we talk about lungs and how they work? So righto, if you get your hands underneath your ribs, it's kind of uncomfortable, and push in a little bit and breathe in and out. It's not fun. There's a muscle that goes down and up called your diaphragm, which allows you to mechanically breathe. And I thought that, you know what, why don't we have a look at what happens with how our lung actually works and how you can really make really simple models will fit a concept. And honestly, that's effectively what you're doing with the Australian Virtual Astronaut Challenge. So you might have seen one of these before. In fact, it's turning up in the folio, the student folios for next week. This is a very simple lung model done with, well, a soft drink bottle. You'll see that the bottom of the bottle has been cut and we've attached a balloon. That's all it is. I can pinch that balloon and move it in and out. You'll see there's a balloon there with a straw and the balloon's been attached with a rubber band. And if I hold this nice and carefully and push this up, the little balloon gets squished. If I go down, it opens up. This is really showing mechanically how our lungs actually work. So when you breathe in, when you're doing your training like an astronaut, getting all nice and fit, your lungs are working hard to get oxygen into your body and carbon dioxide out. And when you go down, your lungs fill. When your diaphragm goes down, your lungs fill. You are opening a space in your chest. You are lowering the pressure in your chest and air rushes in to fill that space. Your lungs work this way. But I tell you what, whilst that's a very simple model, I'll tell you what's coming up is not some, well, showing you how to get complex models done with simple designs and building and building and building them in a 3D environment. And someone who is very good at this, really skilled at this, is Glenn Lawrence. Glenn has been doing this design and drawing for many, many years. And I'd be curious to see what you guys might create in your own videos when you showcase that to us later in about a month or so. But Glenn, is it right if you can unmute your video and really walk us through designing and drawing, getting things out of our head and in a way that works in a 3D environment? Please, Glenn, go for it, mate.
Hi, thanks very much, Ben. And hi to all the teachers that are out there. If you're sitting next to a teacher, then make sure you reach over and give them a big pat on the back. It's a lot of organisation. It's coming along really well. I've been so enjoying all the lessons up till now. So now it's my turn to talk to you today about how you can draw your ideas for design. First of all, can someone give me a thumbs up? Can you guys see this area here okay? Good.
Not right now yet, mate.
So we're looking at
video on your phone. So what you'll need to do is just turn your video on because we've got a second camera going on here. So we want to make sure that
just testing that second camera. So while you get that working, I'm going to talk to you really quickly today about my 3 keys for learning to draw your ideas in 3D, whether you're going to be a designer, whether you're going to be an engineer, a scientist, or a surgeon. Learning to draw in 3D helps you to think in 3D. So the first one of my keys that I'm showing you today is learning to draw long, light lines. So I'm going to place here. So how are we going with that top-down camera?
So we just need to just turn it on there. So I've just sent through a request to ask to start video. So you should be able to click on that and have it just pop on up. Oh, there it is. It is up now, ready to go. Awesome, mate.
Great. Okay, so we're right to go. All right, I am going to grab now. I said earlier that you're going to need a little bit of paper if you can. But while you're doing that, let me show you an example of why we draw. For instance, if most things that you'd want to draw, whether it's scientific apparatus or mechanical engineering, most designs start off with either a cylinder or a cube. So if we practice drawing those 2 3D objects, then we can put them together, we can assemble them for design. And using just these 2 elements and a little bit of practice, I have drawn a Mars rover that is actually called Rover. You can see the cylinders here and just 2 cubes joined together. Now, when I say drawing, a lot of you are probably thinking straight off of blueprints. Blueprints, or plans as you might know them, come a little further down the track. These represent all the measurements and the information that someone would need to build your design. Yeah. So that is plans. Another type of drawing that's more towards the end of the design process is a presentation drawing. So this drawing is for probably non-technical people, so they can get a really quick idea of all the parts and how they assemble. Now, the most valuable type of drawing that I find is more like this. And these quick concept sketches is, for me, where design occurs. So let me show you a few other benefits. For instance, quick sketches keep a record of where I've been. And if I decide that something's not working and I want to go back to where I was, it gives me somewhere to start. So that's one reason. Let me show you a few others. So I'm talking about the types of drawings that are done really quickly. This type of drawing helps me to understand. For instance, with the ExoLab, I had a little look at it, and in my mind, I was trying to take it apart. So this is an exploded drawing where the top's taken off, the bottom's taken off. I'm looking at a module here at the back that could perhaps have a camera and that sort of thing. So then I could extract some of the other parts out and look a little closer. I could draw a detail here of how I could imagine, if this was an apparatus for me, how I could fit this perspex part into the top. So it's these quick sketchy drawings is where design occurs. Let me see if I've got some more here for you. So it might not make too much sense to you. So I try and leave myself clues and I annotate along the way. So I'm thinking about Mars habitats here. And so these types of drawings, not much time to think about what you're doing, just really quick lines. Here's some more. If we're looking at habitats, shall we drill down? Shall we ramp down and have a habitat under the lunar regolith? What shape could it be? Should we build a dome on top? How would we get through the really long cold nights? Will we periods? Will we have light shining in? Could we use the sun to collect heat in thermal mass or under the ground? And then during the cold, we could pump that back in there. So all these types of things are examples of really quick drawings. Yeah. Okay. So where do we start? Well, my number one tip for you was to begin with long, light lines. So if you have that piece of paper, now's the time. So grab your pen. If you've got your pen license, you actually learn faster if you sketch with a pen. And the reason is that students with pencils, if they're drawing a line from A to B and it's not perfect, they tend to want to erase it out. And that wastes valuable time. We don't need it to be perfect. We just need to capture an idea. So here we go. On your piece of paper, I'm going to ask you simply to draw some lines. We're going to make them long from one side of the page to the other, and we're going to go all the way across. Now, your first lines will probably be dark lines because that's the way we usually write. I'm going to bring the pen down here further into my hand, so it's like leaning over further. And if I do that, I should be able to actually draw, let's try and get light lines. So these are like thinking lines. These are the lines that we design with. So work your way, just make sure that you don't flick. That's too fast. If you're drawing too slow, your lines look nervous. Sometimes you might sketch naturally like an artist. That's okay, but it slows us down when we're drawing quick ideas. So we're going to practice drawing some lines. How are yours going? You managed to get them nice and light? Okay, here's a challenge for you. Try drawing up and down the page without spinning your page. Let's have a go. Try and draw some lines up. If your lines are curvy like that, if they're slightly wobbly, don't worry, love your lines. You'll get better with practice. So that is a great exercise for you to try at home. Try and draw some light lines. Now, why would we do that? Let's have a go at drawing some light lines. That is a template for me to sketch inside some circles. So as well as practicing your light lines, why not practice some circles? Maybe I could join those together. Maybe I'm making a robot arm for pollination, to pollinate those plants in the lunar greenhouse. This looks a bit heavy duty. How about we join it with some lighter lines? That looks okay. And once I've got all of the basic layout, I could start and think about what sort of base will I hold that on? Let's round that off. Okay, so now when I've got my basic set out, I could add my design detail, and then I would probably come back only when I'm finished the drawing. I would come back and darken it in. If you've got a thicker pen, you might want to use that too. I like to draw with pencil, and I like to draw with felt tips. Pretty cool. But felt tips aren't so good because if you lean them over to draw line, they work best up and down. So they're probably better just for those finishing lines. Now, drawing quickly too is great. If you happen to have some thin paper like this Bond, then what I can do once I've finished my quick drawings is to place that over the top, and maybe I could use a circle template or just neatly go over my drawing, and that's when I'd render and all that sort of thing. Yeah, so that would be my finished design. If you don't have any thin paper like this, then what you do is take your design and place that on a window, stick your ordinary photocopy paper over the top, and you can trace it off. Okay, moving pretty quickly today, guys. We're going to go on to step 2. Step 2 is to learn how to quickly draw your 5 core objects. And if I draw a sphere, let's make it look a little bit 3D here. Let's add a little bit of shadow. So if this is a sphere, can you think of the other shapes? Yep, we're going to draw a cube. Remember, these are my light thinking lines. So we've got a cube, and let's draw a pyramid, a cylinder, so there's a cylinder, and we have one more shape. Can you guys think what it is? It's going to start off with a square base, and it's a pyramid. So almost, well, actually everything that you want to draw is a variation, is these 5 3D objects squashed in one direction or another. So if you learn to draw all of these, you can draw anything. Now, the good news is that most objects can be drawn, as I said, just with a cube or a prism and a cylinder. So that is key number 2. I would do that and practice it for maybe 2 minutes a day, 1 minute warming up, 1 minute drawing some shapes, cubes, cylinders, and I'm going to give you a bit more of a help with that today. All right, great. So let's move on to step number 3. Combine objects on the isometric axis. So we're going to use this sheet today to help us combine, to help us practice that. But before we get started, let me show you the isometric axis really means drawing some lines at this angle. So these 3 lines are what we call isometric lines. This little splat template helps me draw them, but you could also, if you wanted to, just guess them. Or you could use a set square, a 60-30 set square to help you draw those. All right, so we've got our isometric lines. Now, let's have a go at drawing a cube. So if you're starting from scratch, we will go, let's extend these lines lightly on our isometric axis. This looks like kind of a bird's foot, right? So there's, I sometimes say it's b cubed. The first b is a bird's foot. So we're drawing that shape. Now let's change that bird's foot into what looks like a book. So I'm going to mark off how high I want my cube and then draw 2 more lines. Let's draw the ends of the book there. Okay, so if you can see, that kind of looks like a book, except you can't see the pages going away. All right, so now we've drawn bird's foot, now we've gone book, and finally, we just need these far 2 edges, and we have got our cube. So we've gone from a book to a block with just 2 lines. If you were using a splat, here's how it would look. So I'm drawing my 3 lines, bird's foot. Let's finish the book. And then if we rotate this, we are drawing that. Now, the other thing we'll need to practice is a cylinder. Let's see how that looks using the splat. And let's see how it looks just by hand. If you want to practice drawing cylinders on the isometric axis, remember we've got 3 axes here, we could draw them up and down. We could draw them going this way. So these could be wheels, they could be containers for growing plants in. This and this will get you out of trouble 80% of the time. All right, so let's quickly move on to this page now. We're not drawing on this today. I'm just demonstrating for you. This is in your folio, and you can go to page 20 and page 21 to record your ideas later on back in the classroom. Let's have a look here. This Lego plate really is a combination of some ellipses. An ellipse is where you take a circle and then you slowly turn it side on to draw cylinders. So let's practice just drawing in air around and around, or you will back in the class, and then have a go at drawing it in. This is really important. Practice training your muscles, your arm, to draw in the air. Bring your pen down. 2 lines. Okay, let's finish this one at the back. Okay, maybe we said this is just quick concept sketching. Have a go. There's the bird's foot. Try and take it all the way back to here. Let's draw those lines in. Okay, so we've got a Lego plate. Now, once you know how to draw that, you could, for instance, if I was designing an experiment to test different colored or wavelength LEDs and how my plant would grow, then that would help me to communicate how I'm planning that experiment. So this is like, it's basically a cut down cube. The cube would be this height, and I'm cutting this one down. Now, how can I join these two together? Well, since we've been looking at isometric, let's sketch those lines down and a line back, and I could just connect those with an object like that. Okay, now if I wanted to look what was inside here, another type of drawing is a section. So I could draw side on and I could see my LEDs mounted on there, the legs and my power supply in there. So this line here would be if I cut through here and imagine if I'm cutting from A down to A behind, then this would be called section AA. So there's my LED and there's my section line. I could probably color those. All right, so let's move on. We've drawn a vertical prism and a horizontal prism. Here's where you could practice drawing some cylinders. We've got a Lego round brick here. So this one is just for you to practice and get the feel of it. Once you get your hand moving around like this to draw these ellipses and practice drawing the long ones, let's have a go at drawing our own. Notice it starts off with a center line and then 2 lines crossing that. And that's going to help me center my ellipse. And let's do the bottom one. Connect those. So that is how I draw a cylinder. What about with a little stud on top? Let's go here, around there. Okay, you guys getting the idea? It gets much easier with a little bit of practice. Then we combine to design. Okay, we're going to round up in just a minute. Let me quickly sketch this one in. So I could be designing an experiment where maybe this is like a sensor, a light sensor, a camera, and I'm designing how I'm going to attach. There's my bolts going in there. How can I attach a bracket to mount this to my experiment and all that kind of thing? It is really a big advantage to be able to pick up a pen anywhere and sketch an idea. Okay, I can't design without a pen in my hand, so my wife says. All right, so very good. I would really recommend you to go and practice those light lines, practice drawing some things like that. And I'm going to catch up with you again next week. And hopefully I'm going to ring one of the teachers to put a student on and ask them, have they practiced their light lines? That's what we'll be doing, guys. So I would also like to say that I've been looking at environments for plant growth, and I'm really interested in something like this. And this is from a site called Domerama, and it is a geodesic dome. And between now and next week, I'm going to design a connector to connect all of these little parts together. I have found a few options for cheap objects. I'm going to imagine that I'm stuck at home, and I've found some little Dagwood dog sticks, and I found some PVC tube and a few other things. Between now and next week, I'm going to do some drawings. I'm going to design a connector, and we are going to assemble parts of a geodesic dome for next week, and let's hope it all goes to plan. And if it does go to plan, I'm going to bundle up a couple of kits and offer them out to a few schools who are involved. So thank you so much, teachers. Thank you, the students. Thanks to all the panel. I've learned so much from being involved in this project. I wish this was around when I was a kid. I think the main takeaway is you don't have to be a grown-up to get started on your science or engineering career. With things like this, you can just get started now. So thanks again. And we're going to quickly go to a poll. Let's get a feeling of who's drawing, who's designing experiments, who's designing devices, and who is designing an environment for plant growth. So I'm going to throw it to Jackie now, who's going to set up the poll. Let's get a feeling of who's designing what. Okay, over to you, Jackie.
Yeah, so is that sitting there, so that you should find that your poll will be sitting up there. So if you haven't had a chance to scan the QR code at the start, just look at the very top. You see ahaslides.com/AVAW3. It'll take you straight there. We're kind of curious because, Glenn, there's lots of different ways that we can design stuff, right? And then more importantly, I love how it really is those 5 shapes you're talking about. It's almost like Lego blocks, but done with pens and paper.
That's exactly right, Ben. You'll find that once you start stacking objects on those isometric lines, it is exactly like building with Lego.
Oh, that's awesome. So I'm just curious. I mean, so very, very soon we're going to put up what people are thinking about, what they're thinking about designing. You've got me thinking, I must say, Glenn, about what on earth could be created. And this is the thing, if you're thinking, remember in week 1, as we think about when there's poll results coming up, the week 1, we talked about forming a team. And some people are really, really good at drawing. Other people are really good at speaking, potentially too much. Others are really good at planning and everything else. Think amongst your team who can create things. And I love those things that you're suggesting, Glenn, around what we can do. What we can do is training ourselves. So, Jackie, is it right if we could pop up the results to our poll and see what people are thinking potentially creating? Let's see, Glenn. Let's see if there's any surprises here.
Device. Well, we've got other coming along, but growth experiment. I really thought growth experiment would top the list, but I'm glad to see that people are thinking devices and environments. Look, it's all exciting. If I was designing experiment, I would be really interested. I was inspired by the Exo Lab, and I think on Earth we can't design an experiment based on microgravity here on Earth, but I'd be interested to see how plants grow in lower air pressure, because if plants grow fine in low air pressure, it means that when we make an environment on the moon, we don't have to have necessarily 1 atmosphere pressure. So that's probably what I'd be doing. Device definitely in front. So that's really good to know.
It is fantastic. And I must say, that really brings up a perfect opportunity to chat with our next guest. Thank you so much, Glenn, about this, because designing for for devices that might grow something is fantastic. What on earth will the living things do? And someone who is incredibly good at observational drawing, looking at what's in front of them and putting it down on paper in such a honestly beautiful way, you'll see what I mean very, very soon, is Gillian Hewitt from Imaginaturalists. So Gillian, would you like to show us what you do when it comes to observational drawing?
Hi, everybody. I'm very pleased to be involved in the AVA Challenge. My business is called Imaginaturalists, and it's a bit of a big word, but it's a blend of using our imagination and becoming a naturalist. And so being a naturalist for me is to go out into our beautiful world and to look around me and notice the things that are going on around us in our own environments. So using our very, very special superpower of observation is very, very important. It's a beginning step to lots and lots of science. It's the simple art of being able to see the things that are around you. We have a program that I go into schools, and I look at all these science concepts, but we do it through art activities. So art is a really fun way to learn. Most of us all are always engaged very happily when we're doing artistic things. And drawing is really the best way of seeing. So if we can remember that, it's a good way to stop and take some time to look around the processes of nature, the things that are around us. And when we do that, we notice that each of the things around us are made up of much smaller components. When we stop and look at the details, it's amazing to notice how many smaller things are around us. These days, we've got lots of technology that we can look even closer using microscopes. And if you go down the science trail, you'll be able to access some amazing technology to look super close at things. But the way that we can start down that track is just to use our eyes. And so our brains are quite tricky things. They often trick us into thinking that we already know everything about everything that we think we're informed about. But when you are asked to draw something, it makes you stop and you have to slowly look at the details that make up that object, whatever it is. You might be drawing a plant or an animal or a whole environment, or perhaps even a car. When you're asked to draw it, you're forced to include the details that go together to make up the whole object. And that is where the powers of observation really come into play. So I'm going to share my screen with you for a moment. And we will have a look. So the Imaginaturalist is really about the art of science, being the heart of science. So I strongly believe that art is not separate to science. It's in fact the language of science. And without the ability to communicate through pictures, we would really all struggle to understand complex concepts that we find throughout science. So drawing, as I said, is really the very, very best way of seeing. So in your folio this week, as we're talking about plant growth in space, there are some activities for you to do some observational drawings of plants. So plants are all around us. They're very, very crucial to our life on Earth. In fact, we wouldn't be here without them. And it's a really great way to start your observational drawings. This, of course, is not a plant, it's an eagle. But when you look closely, students can learn the tips and tricks of drawing skills and be able to convey those as information done on paper. And quite often the old adage of a picture is worth 1,000 words is very, very important. We all look for pictures in books to help us to understand things. And when we start to ask important questions which have come from our observation, those are the beginning steps of scientific journeys. So learning to look closely and ask the question, why is it like that? Why did it do it like that? Was it always like that, or has it changed? Many, many scientific journeys have begun with those simple questions. So one of my favorite quotes from Isaac Newton: if I have ever made any valuable discoveries, it has been more due to patient attention than any other talent. And this is true for all elements of science and design. So I'm going to play a little time-lapse video for you in a moment. In your folios this week, we've asked you to collect a plant or something natural from your garden or your own environment, and to stop, to look closely at the object and to try to get down what is important about that object on your piece of paper. Observational drawing is a technique in which you're trying to convey information about the thing that you're looking at, so somebody else can receive information about that object. Now, you don't need to be the world's best skilled artist, and as Glenn mentioned in his previous section, the loose, sketchy lines are often very, very good about conveying information. Doing it really rapidly, like Glenn was saying with his design process, is a really great way to start to get your observations down on paper. And when you start to do that, you'll notice that objects are made up of a lot more detail than you expect. So when you are looking at an object, you start by mapping out the outside exterior of what you're going to draw. You then don't worry about all the fine details. Try to map the entirety of your drawing so that you know it's going to fit, and so that you know that the proportions are going to kind of look correct at the end before you start to put in extra details of what you're looking at. And as you go along, you can build up more and more information. And your drawings don't have to be the world's best artist's drawing. What you're doing is you're looking at all the little fine details that are included in whatever object that you're looking at, and you are including them into a drawing that somebody else hopefully will look at and say, oh, I can see that there's the little triangles at the side of where the seed pods are opening on the Banksia nut. After you've got your basic outline put into play, oh, we're going to have it twice. After you've got your basic outline put into play, add the fine details on the top. You can get dimension into your drawings by adding shading to your object that you've drawn. And those fast gestural lines are often really, really great to remind you about the things that you've been looking at in your environment, and as well as to remind others about the things that you're talking about. So sketchbooks, a little nature notebook, is a great thing to have. And if you try to practice your skills in drawing every now and then, and don't worry about whether you are providing a beautiful finished artwork, you do lots of things. Annotate them, as Glenn said as well. Beautiful labels, sizes, things about the day, the environment of where you collected it are very, very helpful. Now, as you start to notice the things around you, you'll notice the interconnectedness of our environments, and you'll be starting to notice lots of different types of things. And ultimately, you'll get a greater understanding of the world around us. You can take it further with your skill as you go further forward. Scientific illustration is all about conveying information, and it's got a great history of complementing scientific journeys is the job of the scientific illustrator, all the way back in history to when our explorers traveled the world. They would send back images where they were documenting the fabulous and amazing species that they have seen from other places around the world. This can be a picture as we go to space as well, things that could potentially happen. I'll just stop sharing for a moment. I'm going to also briefly mention in the folio sheets, we've got herbarium sheets. So a herbarium sheet is when you basically press a flower or a sample. And here are a bunch of examples that we've done in some classes. Just quickly going to stop sharing for a moment. So herbarium sheets are a really great way of maintaining a species as a record in like a library. It's similar to a library. So in your folio sheets for this week as well, there's another example of how to do this. You can do it as a class, as a group, and make a big stack of pressed flowers, or you can do your own one. If it's just a little flower or something, of course, the easiest way to do that is like with a tissue in the pages of a book. But if you use acid-free paper, you can press them. And if they're done according to the process that I've mentioned, you can keep the color in the flowers or in your samples, and you can have these beautiful, very, very flat specimens that then go into recorded library catalogues in a place called a herbarium, and they can be kept for hundreds of years to keep what they call a type specimen of that plant. This is really, really important because some of those herbarium specimens have become extinct in our world. I'm going to quickly go back to our sharing screen because the last activity in the folio is about using and unleashing your imagination. Now, imagination and creativity is one of the highest regarded skills as you go forward in your lives and go out to get jobs. And people who are not afraid to use their imagination are going to do very well in their future careers. So I'm just going to quickly, briefly go back to our shared screen here because, although it's not clicking over, if we were to go to space in the space station, I have to just briefly go back because my sharing's not working.
That's okay. And whilst that's still happening, I must say, you're taking me back in time. I've got some of these things hanging around at my home from 25 years ago when I made back when I was at uni. This is as you're sort of doing the share screen thing.
Sorry for the tech problems there. Okay, so the last screen that the last few screens that I'm going to do. Oh, I've done it again. The last few things I'm going to discuss are about the last activity in your folio, which is using your creativity. So if you were able to consider the things that are going to happen to a plant in space, on the space station or on Mars, or if it was to grow on Mars, there's a whole variety of different circumstances that those plants would be growing in, different pressure, different amounts of light, different temperature because of the distance from the sun. So I would like you to try to create a new species, to get really creative. There's no correct answer to this question, and it's all about using what we know about plants on Earth, adaptations, and how would they possibly be successful in the environments of Mars or the Moon, or even growing in the space station, which we're going to talk about pretty soon. There's no correct answer. So you can let your imagination run wild. What would plants look like if they could grow on another planet? If they had millions of years to evolve, maybe they would become floating balloons that are not tethered to the soil. If they're in a microgravity environment, who knows? Maybe they might be globulous masses like slime growing over the surface with different pigments because of the different wavelengths of light that are coming to us throughout space. While you're designing your objects or your devices that Glenn has set for you, I want you to remember that probably most of the things that are going to happen on the space station are to create growth of plants that are ultimately going to help us live in space. What happens when we take the pollinators away, the bees, the birds? How do we pollinate? You guys will maybe need to invent a new invention. So the pollination brushes on a conveyor belt to help pollinate. So pollinating one plant by hand as an astronaut in space is probably doable. But if we wanted to live and make a home on the Moon, how are we going to add bacteria to the soils? Another thing I want you to think about when you start to notice the objects and the shapes and the processes on Earth is a beautiful thing called biomimicry. Lots of the forms that we already find in nature are going to offer us solutions to the problems that we're going to have to living in space. So lots of things on Earth. This one is a little skeleton from a unicellular algae that lives in the ocean. But I thought maybe that might be a great option for instead of the dome living on Mars, could have more structural stability. There is a vast amount to look at when we start to enjoy and notice the details of nature. And there's so many things that can be applied to in both space as well as protecting our own environment. and art and using your observation to communicate that is a really, really awesome way to engage in science.
Thank you so much, Gillian, for that. And actually, I must say, that time lapse got me thinking about what Ted has been involved with in the International Space Station. So I'm going to throw it to Ted because Ted can explain this far better than I can. Ted, take it away.
Go. Got the unmute going. Hey, my mind is, all my neurons are firing. Glenn and Gillian, hours with you. I have just thoughts, right? The geodesic domes we're going to hear about next week. Guys, look up Buckminster Fuller, right? The kind of creator of the geodesic dome. And he had something, he thought about our planet as a spaceship. Spaceship Earth was written in 1969. But I'm actually not here to talk about that. Gillian, when she was doing those illustrations, she moved us through time, one of the 4 dimensions that we know about. We go back to what Glenn was showing us, those isometric drawings, and allowed us to see more than one face. You know, we think about the 3 axes, X, Y, and Z, and time is that 4th one. What we're doing in space, you had that quick survey, right? The idea of thinking about a growth environment for your plant, or the device that would actually built in, or the environment that's contained, or maybe you had some other idea. What's interesting here, as you think about what Glenn's sharing with you about how to design your device, and what Gillian's sharing with you about being observant. We have our eyes, we have our other senses as well, right? Touch, taste, our hearing. Make sure you're activating all those. But when you're designing something, you must think about why you're designing it, right? What is your subject? And what you're going to be looking at here real quick is a time lapse of a plant that was living in microgravity, flying around the Earth at 17,500 miles an hour for about 30 days. This was our recent experiment, ExoLab 9. And I believe Physics Education is running this program, and we're getting ready for a much larger investigation a year from now in October of 2022. So if you're thinking about the tools that Glenn's sharing with you and the observational powers that Gillian's now empowering you, we all have superpowers, right? Think about how you might apply that and help us work on an actual mission that will go to space. So here's this time lapse. I probably should have been running it while I was chatting, because I know we're running short on time. And I'm running this double speed, but watch these guys dance. Which way's up? Which way's down? They really don't know. And so while these seeds are germinating, little radicals emerging, honestly, they must be confused. These 3 different tubes all have, each of them, 5 seeds. Not all of them germinated. And they're sitting on a medium called agar. It's a neutral medium. It's basically just water with no nutrients, and the light that we're getting here. What will our plants do? What will your plants do? What would happen, not just in microgravity, but perhaps on the surface of the moon when we have 1/6 of the gravity? I think in our first session, we were comparing the mass differences between the moon and Mars and on Earth. So consider that as well when you're thinking about your design. But look at these little guys dance. One of them's wiggling around looking for the light. The roots really don't know which way to go. Tube number 1, you'll notice it's kind of hard to see because during our mission, when the rocket went up, that the medium that was in there kind of spun around 180 degrees. Something we're going to have to try to fix on the next mission for sure, right? But that's some time lapse. And I'll just quickly end with that. And I want to switch over, and hopefully I want to make sure you can see this. When we get our experiments back, we want to dive in deep. We want to use our powers of observation, but our eyes can only do so much. What happens if we can actually go to a very high wavelength, way past our vision, to X-rays? We went to the National Laboratory at Berkeley here in the United States, and we sent them our plants. This is not our plant in space, but I'll do a quick time lapse of the type of technology that's now available to us, so we can look far, far in more detail than what we can see as humans. Think about that with sound. Think about with maybe taste or touch. With the technologies around us today, what might happen? Oh, of course, it's going to pause. This is the very tip of a small little plant, just the very tip of the root. And if you could see it in high res like I can, you're streaming it right now. It's amazing detail. Imagine sketching this out. How would you look at the structure? Well, those kind of look like the cylinders a little bit. Actually, they're kind of like hexagons, something in between what Glenn was sharing with us. Isn't that fascinating? You know, there's just so much more to talk about. Ben, I want to turn it back over to the rest of the team here and to kind of lead us in more investigations. Thank you so much.
Right, so very happy to be involved. And I must say, ExoLab is an amazing project coming up in October 2022. And that is X-ray tomography that we were seeing just at the end of that there. Now, I do want to throw across to Wendy and Ian, who'll be able to guide us through that student folio that you're working through. And we are up to week 3. Wendy, go ahead.
Oh, thank you very much, Ben. So it's that time of the session where Ian and I are going to walk you through the folio and the activities relating to what you've learnt today. Just a little side note, I remember Gillian at university, I did a herbarium, but with a prawn. It was amazing. Anyway, okay, so I want to recap what we have, where we've come from. So week 1, we learnt about the attributes of a good team, and you all had to work out in who was going to be in your team and what were their abilities and how could you actually work together to get your end product. We also started a quick brainstorm with Ian during week 1, but then that led us into week 2, where we had this most amazing guest, Alan, who helped us drill down on those brainstorming skills. And we defined the problem that we're going to solve. And Ian actually talked to you as well about a Gantt chart to help you manage your project. But this week, before we begin, I'm going to go back to Ian now, and Ian's going to just give us a recap of what our design is about.
Yeah, thank you, Wendy. Just for the students and the teachers out there, it's really important that we continually touch base with what our end goal is with the AVA, or the Australian Virtual Astronaut program. And we're halfway through our 6-week cycle, and just recapping that our goal at the end is to create some sort of a new plant growth mission that Ted and his team can potentially use either on the International Space Station or on the surface of the moon. So just in the back of your mind, just make sure you're always referring back to what is our challenge to complete in this 6-week cycle. And I'll throw back to Wendy now. We're going to start to go through this week's folio. And Jackie, just while we go back to Wendy, can you throw up page 19, please?
Excellent. Thanks, Ian. So you'll find on page 19 that we are in the identify phase. And the first part of identifying our section here is, think about how are you going to assess the success of your design? What criteria do we need? Now, I remember back in week 1, we asked students to think about what different types of ice creams, what flavoured ice creams would they like? And if I'm thinking about the criteria for that, well, I want to know if people liked it or not. And so perhaps I would be at a local supermarket giving out samples and asking them to rate my ice cream from 1 to 5. Now, a lot of you wanted to design a device this week, and I'm thinking, how would you measure the success of your device? A lot of you wanted to do a growth experiment. How are you going to measure the success of a growth experiment? Do you measure the height of the plants? Do you measure their colour in some degree? How would you measure the success? And you write that into the criteria box on that page. Over to you, Ian.
Yeah, thanks, Wendy. So down the bottom of that page, we've got a link there to tools and equipment. And just my advice to teachers is I'd be asking the students to come up with their list of what tools and what equipment they need to be able to complete the task that they're planning on doing. This is a multifaceted task. We have teams and in your school that may be going in different directions. So there's going to be a lot of different types of materials and tools that the students will need. Try and make it as easily accessible as you possibly can. Try and use things from just around the home or things that you don't need to spend too much money on. But one of the things that I would like to talk about in more detail is the safety aspect. So if we're using machinery, we just need to make sure that kids are being safe. The New South Wales Department of Education, for example, has some really good guidelines on their equipment safety in schools that teachers should be referring to. And when it comes to the workspaces, the collaboration spaces are ideally the way to go. So if you can have the students in an environment where they've got large workspaces that they can sit around and collaborate together, and movable furniture, and sort of be a bit more creative and allow that collaboration to occur. Wendy, I'm going to go over now to the next session, I believe. So Jackie, I think we need to go to page, let's see.
Let's go to page 29, Ian, about the mission patches.
Actually, page 29, yes. And my project, that's my section. Okay, this is a really fun activity. I played with this just the last few days, and I found it really engaging, and I'm sure that a lot of the students out there are going to find this really engaging as well. The idea of the mission patches. So I'm just going to hold up an example of a mission patch, as you can see here. So this is a mission patch from ExoLab 8, which is part of what Ted's been talking about with his experiments on the International Space Centre. And I was lucky enough a number of years ago to go to the United States and go to the Kennedy Space Centre, and I saw a presentation by an astronaut who, during the presentation, he spoke about the mission patches. And I wasn't aware at the time, but every time they fly a mission into space, the astronauts have a special patch that gets designed for them that goes onto their spacesuit. And it's obviously something that's a really highly prized and a real proud thing for them. So with our challenge, we'd like you to maybe look at, can you design a mission patch for your team? And there are some tools that will allow you to do that. And on our page that we have here, there is a link to a missionpatch.com, and it's a really intuitive, very easy to use software application that's freely available online. It has a whole range of different types of ideas that you can meld into your mission patch. And we also have on that page there a link to a YouTube channel which talks about what are the meaning of those patches. Before I go on to designing the patch, I want to throw over to Ted, because Ted has a number of amazing patches that I think he would love to share with us. Are you there, Ted?
I am. Yes, this is so amazing. Patches, when you have a mission, they're memorable, right? And before you've prepared it, in a way, as you think about what you're trying to do, you can kind of have something that represents your idea. And so since we've run a number of missions in space, there's quite a few patches that are memorable for me. This was our first mission to the space station in 2017, SpaceX Dragon. It's very detailed. You can see that the Dragon's represented here, the space station itself, and of course our Earth. But you don't always need to be so very specific. Look at this one with an octopus. It was the 8th mission for this particular rocket. And so they wanted to add some different colors and what have you. My favorite, we came back on the Crew 1 Dragon, right? It's the first time that the SpaceX Dragon brought people back to Earth. And of course, Ian showed you ExoLab 8, here's 9. What will your patch do based on what you're trying to do in space? Maybe it's a home on the moon. Maybe it's about growing plants with us. We'd love to see your ideas. Back to you.
Oh, thanks very much, Ted. That is absolutely amazing. I have no patches, so I'm on a mission myself. So guys, we're now looking at page 32, because when we are planning our experiment, do we just do our experiment straight away? What if it doesn't work? Or do we actually create something first and test out our idea at a small scale? So a lot of you were talking about a device, and on this page you can see there's a rocket, and this person was creating a rocket that they were going to use for their experiment. So they actually tried it out first on a small scale and then made adjustments before they went to their full-on big scale. On page 33, this is where you need to plan your experiment in more detail. So you need to write out your aim. What are you actually wanting to achieve? You need to write out your method. What's going to be the steps that you take to do your experiment? Then you test it and you write out the results. Now remember, the scientific method does flow back to the top. If you don't get results that make sense, or you want to test something else out, you go back, adjust your aim and start again. So that's where we're at with your experiments. And I hope that does set you up for the following week, during the week, and then next week we'll continue on with this. But, I'm just going to pass over to Ian, because we're now going to talk about exercise in space and link this all back to our heart and brain again.
Thanks, Wendy. We had Ben come on last week and this week and showed the students how the heart worked, and also this week the really cool experiment about how the lungs work. And it's really important to realise that astronauts or people that go into space, they they need to have a certain skill set, obviously, but they also need to be physically and mentally fit. And there's an old saying that if you've got a healthy body leads to a healthy mind. And when you're up in space, you can't afford to get sick. You can't pop out to the chemist or go and see your doctor or take some headache tablets or something with you. So exercise is a really important thing. And we have a couple of pages here on how to train like an astronaut. A couple of things I'd like to point out. You don't need anything expensive to train. You don't need to go and buy expensive weights or gym gear or get a gym membership. There's a whole stack of really simple things that we can do just around our own home to get physically active. Even just going for a walk every day, it's amazing how much of an impact that can have on your health. And I think Ben made a challenge last week to see if we can get our heart rate to come down between week 2 and week 6. So little things like that can really be beneficial. The other thing I want to talk about is we talk about teams, and your school has teachers, and they're a team. So even though you might have a teacher that's helping you at the moment with the AVA, you might have other staff in your school who are experts in health and fitness. So you might be in a high school, so obviously your PE staff, or if you're in a primary school, you might have a teacher or a group of teachers that sort of specialise in that sporting area. So reach out to the members of the school team to see what you can do to try and get yourself a little bit more physically fit, and take up Ben's challenge from last week. Try and get your heart rate down between last week and our last week of the challenge, and talk to your teachers about what you can do to make that happen. And perhaps teachers with your weekly meetups with your students, set aside 3 or 4 minutes at the start and the end of the lesson to do a couple of basic exercises. Now, Wendy's going to finish off our folio on page 35. So, Jackie, if you bring up page 35, and I'll throw over to Wendy.
Now, Ian, I am definitely not doing a burpee for everybody. That would be embarrassing. But on these 2 pages, we talk about how to do a burpee, because they actually develop your muscle condition and your coordination. And so we would invite you guys, your students and teachers, to find an open space and to test out a burpee. And at the bottom of page 35, there's actually a mission challenge. Stepping out there, how many burpees can you properly do in 30 seconds? And remember, when you're jumping up and you curl up your knees, you shout out, lift off. So yes, give that a go when you possibly can. Now, I would just want to have a quick chat about the AHA slides for Jackie. So throughout the AHA slides, you'll find there are quizzes. We don't actually go through all of those in our sessions, but you can definitely answer the quizzes and go back to the previous week's AHA slides and answer those for us. So now I'll just pass over to Ben. Thank you.
Look, thanks so much, Wendy and Ian, for guiding us through. And guys, we are at the end. We're only a minute or 2 over, and we are about to kick off. But you might be wondering, what is coming up next week? A lot. Glenn's coming back to us to describe a bit more about the geodesic domes, and a lot about blueprinting and more getting your ideas down onto paper. Ian and Wendy are going to take us through a couple of different software applications that allow you to do some computer-aided design. That is really neat, especially when you look at what happens in space. Now, you might remember Laurie Waters from Magnitude.io joined us earlier on during this design challenge. Well, she's coming back, and more importantly, she's been somewhere. And she's going to describe what she does with analog astronaut missions. I'm just going to leave her hanging for a moment. You'll be surprised what she's been getting up to. And we do also have another guest, Kirsten Banks, who is an astrophysicist finishing off her PhD at the University of Sydney and is involved with Australian space in a lot of different ways, I must say. And by the way, if you're wondering about what Kirsten Banks does, she's heavily involved in science communication on TikTok and doing an amazing job with that too. So I do want to say thank you very much for everyone who's been involved. And so if all the people who are currently, could you please turn on your videos? I'm going to quickly go to a different view so we can all see everyone. There we all are. We'll wave goodbye. Thank you so much for coming along. And we'll see you in week 4 coming up, Australian Virtual Astronaut Challenge. All the best, guys. Have a fantastic morning, or if you're watching this, an afternoon or evening on the recording. All the best.